Hello and welcome back to Mikey's Flightdeck. Today I will show you how you can cut and engrave your own EFIS panel. For the first engravings I've ordered some test pieces of plexiglass. It's a white 3mm thick acrylic glass where 30% of the light comes through. I've seen some builds that have a clear 3mm acrylic glass behind this one, so I will end up with a thickness of 6mm. By the way, the real Boeing panels have a thickness of 5.4mm. But before we start to paint these, we will have to get rid of these stickers here. You can't make any good engravings on a sacrificial layer that is used like this here. But instead of making a new layer, which will also be used in some time, I will remove this here and put on a sheet of MDF on it here. And I will let the machine cut a pocket inside, only 1.5mm deep. But then I will have a perfectly flat surface. And this surface will also be aligned to the axis of the CNC. The surface is finished and I can start the first engraving test now. By the way, this is one of the plates I've painted. It came out really nice here, but I will need a little bit more training in painting these things because the smallest air bubble on the surface will destroy the whole smoothness of the thing, and there are some air bubbles in it. We will see if I can get this out in the future. But back to the engraving. When you want to engrave your panel, you have cut and drilled holes in it before. And after this, you want the engraving to be on the exact position it has to be. And to ensure this, the CNC machine has to know the orientation of this plate and where the surface is. And to ensure this, I've made such an edge finding tool here. I think you can see it better here. It's in just two angles, two rectangular angles, an outside angle and an inside angle here. And when I lay this down on the surface of this panel, I can touch some points with the router bit. And so the machine can calculate where some positions are. For example, it will touch the surface of this plate here, and because the machine knows the thickness of this plate, it can calculate where exactly the surface of the panel is. Then it will touch these 3 points here, and with these points it can calculate the orientation of the panel to all the axes. The backlighting came out really well from the first try, and instead of making a long try and error video, I decided to make some more test engravings, which we go through now in detail. The big rectangle has a distance of 10mm to all the outsides. This ensured that the orientation of the panel was done correctly. These thin lines come out very clear, but they aren't visible when the backlighting is off. I tested two different letter sizes of 2.5 and 3 millimeters. and different line sizes of 1, 0.4, 0.8 and 0.6 millimeters. And now don't lose any more time and let's start designing the EFIS panel. When you are looking for panel measurements of the Boeing, I would recommend you to look first in the Bible of Homecockpit building from Marcus Pilot. Here you can find all the measurements you need and it is always a good place to start. Although Thingiverse is worth a look, here you can see what I found when I searched for Boeing EFIS, and there are 2 EFIS panels you can import into your 3D program, and these can act as a base for your further development. Also, GrabCAD can be a good site for this. Here you can see full designed EFIS panels, even with all the needed buttons. I was lucky enough that a viewer of my channel shared his panel drawings with me. He made in CorelDRAW, and I could use them as a base for my development and adapted them in some parts to my needs. When you have made a drawing in CorelDRAW or Illustrator, Inkscape or any other vector-based program, then you should export your file as a DXF file for the upcoming engraving. And I can show you this for CorelDRAW, for example. You just go to File, say Save As, and here you can choose the DXF AutoCAD format. Then save it. I left all the settings as they were. And I have made a DXF file from this panel. I now want to import my DXF file into Fusion 360 because I will work most of the time in this program just because I'm more familiar with it as CorelDRAW or Illustrator. I can go to Upload and drag the DXF file here. After the upload is finished, you will find the file here on the left and can double click to open it. And we see all the lines that there were as in CorelDRAW. But there are some things we have to change before we import it here, and I want to show you these. You can see that the rectangles that were there in the file are now just lines. And we can't say Estlcam that it should engrave this line with a width of, for example, 0.5 millimeters. So we need to make these 2 rectangles. And also the rings around these holes here are now just lines. We'll have to change this also. And in CorelDRAW, this is really easy. You just have to select the items you want to convert and then say Object and Convert Outlines to Object. After we imported this file again, you now can see the rectangles and also the rings around the holes here. I don't want to bore you with showing every change I've made to this file, but I want to summarize some of these. I changed the width of these rectangles here to 11 millimeters and also changed the distance from this outer ring to this hole to 1 millimeter. All the thickness of these lines will be 0.7 millimeters except of the 2 rings here, which will be 0.5 millimeters. You might have seen that there are no texts on this file here, and this is no problem because I want to set the text in Estlcam because I have some more options to engrave this there. So when you are done with your changes to this file, you stop the sketch And then you can right click on your sketch file here and say Save as DXF. In Estlcam, I will open my file, say that the length unit will be millimeter, and select my 2mm single flute bit for cutting acrylic. We have to cut out some parts. And first of all, there is this panel, of course. It is a part. And I will mark this. And because I will cut it from 3mm acrylic, I will set 4mm as my cutting depth. Also, I will place some holding tabs to hold this in the acrylic before I can remove it. And these tabs will have a length of 1.5mm and the same height. And we'll place these tabs here and on the other side. There are some holes to drill, and so I will select the drill tool and mark the helical drill. With this option, I can drill any size of hole I want with only one drill bit, as long as the drill bit is small enough to fit into this hole. I have a 2mm bit and I have to drill some 4mm holes here. So I can mark these holes, then mark them again and set the toolpath depth for all the 4 holes together of 4mm. Now there are the remaining cutouts. I will choose the hole tool and then mark just the holes here. Then mark them all together and set the depth also of 4mm. And now the panel is ready to be cut out. But because we need 2 of them, I will add a second one to my CNC program. And you can do this with the tile tool. So I mark all the passes, go to tile, and you can set how many copies you want to add. I will just need 1 copy in the Y direction. There is one option here, machine individually, and you can select this option if you have to fear that there could be a connection error to your controller card. And when you select this option, the machine will first finish the first panel here before it went on to cut out the next panel. If the option is unchecked, then on both panels here, first of all cutouts will be made, and after this, the panel will be fully cut out. For me, I will choose the machine individually option just to be safe. Now, after all the settings are done, I can go to File and say Save CNC Program. To cut off the needed piece of the acrylic, I marked the cutting line and used the jigsaw with a fine blade. As you have seen in the Estlcam file before, I have arranged the captain's and first officer's EFIS panel above each other, and I've cut the piece with a little bit more extra space for clamping, and I will plate this here in the middle of the sacrificial layer, clamp it, and then start the cutting process.
You can see me wiping off the acrylic chips with a brush from time to time to prevent them from being melted to the router bit.
The panel came out really well. Everything has been cut out as it's supposed to be. I have to mention one thing, because I had problems with my router bit when I started the second panel. A bulk of melted acrylic formed around it, and this bulk got really hard when it cooled down and damaged the panel surface, so I had to change the router bit. Now I'm driving my CNC spindle at 5000 RPMs, and so should you. Watch out that your router bit doesn't get too hot, maybe because of too high RPMs or too fast moving through the acrylic.
There aren't any buttons included in this file, and so I have to make my own. And first of all, I will make the buttons for these rectangular cutouts here. They have a width of 11 millimeters, and so I think 9.5 millimeters should fit really well. So I create a new rectangle here, which will be 9.5 and 9.5 millimeters. Now I will add a fillet to all the four corners of 1.75 millimeters. And here we have the finished buttons. But we also need a button for these round openings here. They have a width of 9 millimeters, and I think 8 millimeters should fit in there. So I make a new circle of 8 millimeters, and it's so easy at this. This is a button. I will stop the sketch and export the new DXF file. In Estlcam, I open the edited DXF file and concentrate on the new buttons here. I will cut out them with a 2mm router and select the part tool. I also want to cut these out from a 3mm acrylic, so again 4mm should be fine. And for not let the buttons fly around when they are cut out, I will again placing some holding tabs on all four corners. I will need 14 buttons for the two EFIS, and let's create 2 more if any mistakes will happen. Again, we can do this with the tile tool. We will make 2 copies in the X direction and 8 in the Y direction. Now there are missing the last round buttons here, and I will select the part tool, the outline of the button, again 4mm tool depth, and I will place 2 holding tabs at the sides. Now I have to move this because it can't be cut out at this place. And this you can do with the move tool. Just drag it up here. And then make 4 other copies for the last buttons. And this should be the file we can use with our CNC machine. Just go to File and Save as CNC program. buttons I will use are made of 3 layers. First of all, the white acrylic layer, you have seen the cutout right now. Underneath, a clear layer which had the same dimensions as this white layer. And the bottom will be a bigger clear layer that will prevent the button from sliding through its hole and will help to fit it on a stick, which will then fit onto a tactile switch. And I will create this bigger bottom layer now, again with a rectangle, and I will use a width of 12 millimeters. I will ensure that the rectangle surrounds this button on all the sides with the same distance, and I will use a little help here. I will create a construction line on the left and the right side, also on the top and bottom side. And then add a constraint which will say that the lines above each other will have the same length. And so the button will slide into the middle. The bottom layer has also a little cutout in the middle for mounting it on a stick. And this we will create with another rectangle of 3 millimeters. And here we also will use this trick to align it to the center. The bigger bottom layer will also be neat for this round button here. And so we will create another circle with 10 millimeters. That's it. And we can use this modified file in Estlcam. To prepare a better surface for the upcoming paint, I washed and sanded the panels. So let's come to the fun part of the project now, the engraving. But before we start, I will add a little help for the engraving on the buttons. And I will add a center rectangle in the construction mode here in the middle of this button. My text will have a line height of 3.5 millimeters, and let's say the rectangle will be 7.7 millimeters wide. So now we get rid of these diagonal lines because these would also be visible in Estlcam later. And now we have a rectangle which will be visible in Estlcam later, and with this left bottom point here we can align our text later good on the button. You also could add these rectangles here on the different places on the panel to show where later the text has to be, but I found it easier to just put on the text and align it by hand. In Estlcam I've opened my new exported DXF file and have chosen the 30-degree engraving tool. Now I will start with this button here. And to place some text, I will go to the text tool and mark my beginning point, which will be the left bottom point here. And now I will choose the font I will use. For my panel, I used the Futura font, and especially the Futura MD CNBT. which is a condensed version of this font, which you can use when you only have very little space here to place some text. The format here should be familiar for those of you who have seen some website programming, for example, or adding different font size in any forums, for example. The tags start with different letters. Here you can see the starting tag with an F for font, and here with a backslash, a closing tag. Between these tags, there will be the text placed, for example, the weather button. And you can see here it appears, but it is too small now. So my font height will be 3, but I can edit this 3.5 millimeters. And here can be some errors because the text always has to be between the tags. So between this new S tags for size. So, and here you can see the VXR in the right size. I will also center the text, and now it is surrounded by this center text here. And I have to change the text width to our 7.7 millimeters. And now it is placed in the center of the button. Now we have to choose a style how we remove the material. You can move material outside around these letters or inside these letters, and this is what we want to do. We choose the pocket inside. We can have a preview here, and this is how the text should look like. When you now click OK, every time you reselect this text, you can edit it. For example, the size, the font, or the text itself. But when you move this text in this state, for example to here, and then you edit it back, it goes back to the same place. So when you want to change the position or any other things on this text, you have to explode it here as a text object and say OK. And now when you mark this, you will see the known property window and you can't edit the text anymore. So this should be clear when you are working with text. I have done a single file for every text object of the button I had to make, and I then loaded these files and exported it as a CNC program for every button I had to make. But now let's come to the panel. I choose my font tool and place the text somewhere here. Choose my font and a text height, which will be again 3.5 millimeters. Again, I'm placing some text width, and the text I will start with a VOR 1, adapt the text width, and choose again pocket inside. I will copy this code to my clipboard so I can use it for the next text object. Mark the explode text object and click OK. And now I can move this VOR object to the place where I want to have it. For example, like here. And this is what you do with the other text. For example, I've made another text object here for the numbers. You have to choose again the pocket inside and say OK. And then I moved this number here somewhere where I thought it should be. You can take a reference image of an EFIS panel and then compare your letters with the letters on your preferred panel. There are also some lines on this panel, and these lines can be done just by selecting the hole tool, and you can select all the lines you need. I will do this with these four, for example. Mark them and say again a depth of 0.17 millimeters. And my pocketing strategy will be a linear and say it should route these out as a pocket. And now they are filled and will be fully routed out. The holes here above or at the sides are a little bit more tricky. You will need to select the hole tool for the inner and outer circle and choose Island. And then the program will route out this circle. Again, select the tool depth of 0.7 millimeters. When everything is done, it could look like this here, saved as a CNC program and sent to your CNC router.
The paint is ready. The panel has dried for a day now, and now we can start the engraving. And as I said before, when you want to come out with a good engraving, the orientation of the panel to the CNC is very critical. I will place it here on the surface and fix it with some double-sided tape, and then check the orientation of the panel with my homemade edge finder. I used a little bit too much tape to secure it, which made it difficult to remove it later. In Estlcam, I used the automatic touch-off to start the alignment process. Now, after the three parts of the buttons are glued together, they are ready for engraving. And before that, they must be painted black. And to ensure that the light still can come to the engraving, the backside must be clear. And to ensure this, I will put them on some double-sided tape here, and I also fix them while I paint them. And that wasn't the best idea I had. I will try to explain it to you. When you stick such a small button onto the tape and you spray your paint layer by layer onto it, then a film of paint will build on the tape, and this film will make it very difficult to remove this button later. Maybe some paint will go off or something like this, or the button won't come off anyway. So when you paint those buttons, then push them on a stick or a screw or something like this, and then paint them standing free in the air. So I removed all the buttons and washed the paint away, and then I saw at 4 of the buttons paint has come into the sandwiches of this button. And I think you can't see this here, but there are 3 layers and there are gaps between these layers, maybe. And when you don't use enough glue to glue these layers together, then there can be a gap and paint can come between these buttons. And this paint would hold the light from going to the surface here. So when you glue these layers together, make sure that you use enough glue so that all the gaps are closed. I wrapped the lower plate of the buttons into some tape to ensure that neither paint nor hot glue will stick to it. as you have learned, the orientation of the button to the axis of the CNC is critical for a good engraving. But of course, I can't use my edge finding jig here to align this small button to all the axes. This won't work. And so I searched for another method, and I've made a cutout into a rest piece of acrylic here, which has the exact dimensions of the lower plate of this button. And I will place this acrylic holder here on my surface, align it with my edge finding jig, and then I know exactly the position and the orientation of this button when I will clamp it in here, and so I can engrave it.
Because of differences in the button heights, I had to zero the Z-axis for every button.
After another coat of clear varnish, the panel and the buttons are finally finished. And what can I say? This came out fantastic, maybe better than I expected. Especially when you keep in mind that all this engraving is done on a homemade wooden CNC. So beside all this happiness, I have to mention that this isn't the technique you would choose when you have to earn your money with engraving panels. There is a lot of handwork in it, and many of the processes are very slow. But for us, who are making this engraving as part of their hobbies, this is absolutely okay. So I will look forward to the next steps in the cockpit. Don't forget to join my live stream on the next weekend. And if you haven't done it already, then subscribe to my channel to stay informed about any upcoming new video from me. So I hope we'll see us soon back on the flight deck.